So some basic science about the Earth, Moon, and Sun. So first of all, here's my models. They're not to scale. The Earth is to scale. The Moon's about 1/4 the diameter of Earth. So the distance of it would be about 30 Earth diameters away. So this would be like 30 feet away from here in this scale. Now the Sun is a lot bigger than that. It's about 100 Earths in diameter, or 110, and it's about the size of a tree. So I don't have a ball that big. So the distance of the Sun to the Earth is about 100 million miles. So basically about 110 sun diameters, which is the Sun being the size of a tree, so it's 100 times the size of a tree away. One interesting approximation is that the Sun is 110 sun distances away from Earth, and the size of the Sun is about 110 Earth diameters. So 110 sun diameters to the Earth, and the size of the Sun 110 Earth diameters. Some people claim that water can't stay on a ball that's spinning. Well, first of all, the water layer on the Earth is super thin, thinner than a sheet of saran wrap. So you just have a tiny layer on that, and the Earth rotation is super slow because it rotates once every day. So imagine how slow that is. So it's not like the flat earthers say, but it's spinning really fast. Now, approximation of the atmosphere thickness is essentially the thickness of a sheet of saran wrap. So our atmosphere is very thin, and it's held on by the gravitational forces. So let's now talk about orbits. Earth orbits the Sun, of course, once a year, and the orbit is essentially perfectly circular, slightly elliptical. It's always exaggerated in science books. So it goes around. It's also rotating on its axis with a slight tilt as it goes around the Sun. The Sun, of course, is also rotating. Now the Moon orbits around Earth. And if you look at the Moon, let's say the 4x, it's a reminder that this Earth is 4 times the diameter. Imagine if the 4x is the dark side of the Moon. We call it dark because it's the side always facing Earth. It's not always dark. So as it goes around Earth, of course it is rotating on its own axis, but very slowly, to do one full rotation every 28 days approximately. If it didn't rotate on its axis, then it would be like this, and the dark side would, or the side facing us, wouldn't be geostationary, wouldn't be tidally locked. Now there's a moon of Pluto where the rotation of Pluto and its moon are perfectly matched. They're both, it's doubly tidally locked. So we'll do some stuff about how do you see a full moon versus a crescent moon. Do this would be better at night. So there's our model of the Sun. It's actually should be like basically 100 feet high in size for the size of our Earth, disco ball, and the Moon. So as you can see, I illustrate with the light beam going to the Moon, and you see what it would be a half moon from the Earth. If you were on this part of the Earth, you would be seeing half a moon, even in the daytime, because you're getting the light from the Sun, and you'd see the Moon. Now when the Moon is here and Earth is here, right? So you have say it's nighttime, right? So you're on this side of the earth, and it would be a full moon. Now, nighttime, you'd have the different phases of the moon. The phases of the moon change depending on where you are, but the moon is always just half lit from the sun.